Hi, so this is our chapter 15. My name is Hope Saeed.
My name is Alyssa.
My name is Matt.
My name is Mary Angela Michaud.
So the first thing we're gonna discuss is the KE. So if the KQ value is less than 1, then there's more product mole presented than the reactant. And then if KEQ is less than 1, then there's more reactant than product. So with that being said, you have the KC, which is reactant or product or reactant. And then we also have the formula for KP. So in order to find KP, it's equal to KC, and then in the parentheses, RT, which is the temperature, and then over delta N. So R is usually given to you, and T is the temperature, which is usually in kelvins.
Okay, so for equilibrium, at equilibrium, the concentrations of reactants and products remain constant, and if the conditions change, then the concentrations shift until the equilibrium is restored. So it's important to note that the equilibrium constant K stays the same unless the temperature changes. For the Le Chatelier's principle, a system at equilibrium responds to disturbances by shifting the equilibrium to minimize the disturbances, and the disturbances include changing the concentration of the reactants and products, changing the volume or pressure, and changing the temperature. For adding and removing reactants, when we add a reactant, the forward reaction rate increases and the system shifts right towards the products. And when we remove a reactant, then the forward reaction rate decreases and the system shifts left toward the reactants. So the effect of the concentration changes is when we add a reactant, the reactants decrease and the products increase. When we remove a product, then the reactants increase and it increases the other products. So a general rule for equilibrium is the equilibrium shifts away from added substances and the equilibrium shifts towards the removed substances. And it's important to note that solids and liquids don't affect equilibrium.
Mine is basically same thing, talking about the La Chatelier principle and about the effect it will have on the products and reactants and the K equilibrium and how it only shifts during when you change the temperature. But it also includes changing the volume itself and what it'll do on the equilibrium, depending on how much you take out and how much you increase the volume of. It can it's what's the word? It's related to the partial pressure and how much it affects the volume if you take out pressure or take out more temperature. And it basically relates to just they're all connected, the volume and the temperature, how they're inverse relationships. And yeah, that's what you
And I'm going to talk about the effect of concentration change on equilibrium. So what happened when you add or what happened when you remove it. And also, we also talk about the general rule, Le Chatelier principle, when we said that the equilibrium shift away from added chemical and the equilibrium shift toward removed chemical. We also talk about the effect that it has on the volume, that when we decrease the volume, there is the increase in gas concentration, and when we increase the volume, the equilibrium shift toward where there's more gas, and that the K stay constant and only the concentration change. We also talked about volume over pressure example, and we also talked about the temperature change, about exothermic reaction and endothermic reaction. And exothermic, it's equal to product, so more heat, less product. And endothermic reaction, it's heat equal to reactant. more heat equal to more reactant. We also talked about, to finish this chapter, about catalyst. We said that the catalyst do not change equilibrium position or key. They speed up both forward and reverse reaction equally. For this chapter, for me to understand the chapter, since this chapter was very close to the test, the practice question helped, because the practice question summarized a little bit what the chapter was about and how the chapter was, and also the homework for chapter 15 to help a little about the chapter. And that's it for our chapter 15, equilibrium. Thank you.
Thank you.
Thank you.